Mean and variance of a random variable. In this module, you will learn about the mean and variance of a random variable. Let us first recall the definition of a random variable. A random variable is a real-valued function whose domain is the sample space of a random experiment. It is the numerical outcome of a random process or experiment. Let us look at an example. A coin is tossed once. The sample space will be capital H and capital T. Let us consider an experiment of tossing a coin twice. The sample space is S with elements HH, HT, TH and TT. If capital X represents the number of heads, then X is a random variable, and for each outcome its value is given by X of HH is 2, X of HT is 1, X of TH is 1 and X of TT is 0. Capital X can take the value 2, 1 and 0. We now define the probability distribution of a random variable. Let capital X be a random variable defined on sample space S. Let x1, x2 up to xn be the elements of domain capital X. A probability distribution of a random variable capital X is a function satisfying the following properties. The probability that X can take specific values capital P of capital X equals Xi equals Pi. P of X is non-negative for all real X. Sigma I equals 1 to n Pi equals 1. Probability distribution of capital X is given by the ordered pair Xi Pi I equals 1 to and is called the probability distribution of capital X. Let us look at an example. A coin is tossed twice. The outcome will be TT, HT, TH and HH. Let capital X represent the number of heads. Then capital X can take the values 0, 1, 1 and 2. Corresponding to each value of capital X, there exists capital P of capital X equals Pi. The probability distribution will be given by. Let us now recall the definition of mean. Mean is a measure of location or central tendency which locates a middle or an average value of the given data. It is a number which gives a central value. For a given frequency distribution, mean x bar is given by x bar equals sigma fi xi divided by sigma fi. A table is given below. Calculate the mean for the given data. Solution. We use the formula x bar equals sigma I equals 1 to n fi xi whole divided by capital N. Next, we discuss the mean of a random variable. Let capital X be a random variable whose possible values x1, x2 up till xn occur with probabilities p1, p2 up till pn. Then the probability distribution is given by Mu mean for probability distribution is defined as this results in sigma I equals 1 to n pi xi as the denominator sigma pi equals 1. E of x equals mu equals sigma I equals 1 to n pi xi. It is also called the expectation of capital X. Let us look at an example. A coin is tossed twice. Calculate the mean for the data. Solution. In the previous frames, we have already constructed the probability distribution table. We now calculate the mean for the given data, which is given by sigma I equals 1 to n pi xi. The value of mean results in 1. We will now discuss the variance of a random variable. Variance is the measure of dispersion or scatter in data. For any given data x1, x2 up till xn with frequencies f1, f2 up till fn, the variance is given by. Next, we associate the variance with the probability distribution. Let capital X be a random variable whose possible values x1, x2 up till xn occur with probabilities p1, p2 up till pn. The variance of a random variable capital X is given by sigma I equals 1 to n xi minus mu whole square into pi. The variance of a random variable capital X is given by sigma I equals 1 to n xi minus mu whole square into pi. Applying the formula a minus b whole square equals a square minus 2ab plus b square, we get sigma I equals 1 to n xi square minus 2 mu xi plus mu square within brackets into pi. This equals sigma I equals 1 to n xi square into pi minus 2 mu xi into pi plus mu square into pi. This equals sigma I equals 1 to n xi square into pi minus sigma I equals 1 to n 2 mu xi into pi plus sigma I equals 1 to n mu square into pi. This equals sigma I equals 1 to n xi square into pi minus 2 mu sigma I equals 1 to n xi into pi plus mu square sigma I equals 1 to n pi. Applying sigma I equals 1 to n xi into pi equals mu and sigma I equals 1 to n pi equals 1. This equals sigma I equals 1 to n xi square into pi minus 2 mu into mu plus mu square into 1. This equals sigma I equals 1 to n xi square into pi minus 2 mu square plus mu square. This equals sigma I equals 1 to n xi square into pi minus mu square. This results in variance of capital X equals E of capital X square minus capital E of capital X whole square. Now consider an example. Roll a dice once and let capital X be an experiment of getting a number 1, 2, 3, 4, 5 and 6. Then capital X will have elements 1, 2, 3, 4, 5 and 6. P of x will be given by 1 by 6 for all values of x. The mean and variance will be given by In this module, you have learnt about the mean and variance of a random variable.